Supplies. The first item on our list are candles. We have both an orange and a white candle. The orange one being pumpkin scent and the white being, I believe, lavender. Then we have 2 aluminum cans, one being wider and smaller, one being thinner and longer. Next, we have sandpaper, and we also have a pack of microwavable popcorn, the butter kind from Costco. And lastly, we have some pliers to cut through aluminum and just a whole bin of popcorn kernels from Cárdenas, so without the butter. Here is a close-up of all the supplies used in this lab. First, we have the sandpaper. Then we also have the microwavable popcorn. We have the bin of popcorn kernels, pliers to cut through aluminum, candles, and 2 aluminum cans. And although it is not included, a lighter was also used. To begin, one must grab the thinner, longer aluminum can and draw a rectangular box around one side, ensuring that they erase a part of the width. After one has finished drawing the box with some form of permanent marker, preferably a Sharpie, but here we use Expo marker, one may begin to cut out the box with the pliers. Now, one must also ensure that they do not go over the lines, the back lines drawn in this case, because if so, it can result in the outcome of this can, or the first can, not turning out well, which will in turn affect the rest of the lab. Please take note that the person cutting the aluminum cans is experienced and that no persons nor person were hurt in the making of this video. Thank you. Once one has finished cutting and have left a little part of the rectangle uncut, one can see that it leaves a little opening on the aluminum can. This is very crucial, for it is where the popcorn will come out and where the popcorn kernels will be inserted. Next, one will grab the other aluminum can, the smaller, wider one in this case, and cut off the top. They can just draw a simple line all around the top, like near the top of the can, and then begin to cut it with the pliers. But please be careful, it is very dangerous, and if one can find an adult to do it, then please go ahead, why not? Once one has finished cutting off the black line with the pliers, they will notice that it's just a big opening, and then they can begin to draw the next part, which is 2 rectangles along the opposite sides of the outer parts of the can. Once they have completed drawing this, they may begin cutting with the pliers. As one finishes cutting, they will notice that the can still has its bottom, meaning that something would be placed there, and it would be the candles in this case. And they're going to see that there's 2 openings along the sides and 2 rectangles that are right across from one another, which will play a crucial part in this lab. Now, the next step is not needed, but it is highly recommended. One can use the sandpaper to remove the paint off of the aluminum can. If not, then the paint can melt from the candle. So please be aware that this may cause dripping and a mess. So it would be preferable and highly recommended for one to sand the can before placing the candle and lighting it. Although these parts are not necessarily included in the video, after one has finished sanding off the smaller, wider aluminum can, one can place the candle in and then take the longer, thinner aluminum can and tape it to the top. One does not necessarily have to tape it, but for our group 4 project, this group did tape it. One can find other ways like a hot glue gun, but it ultimately is whatever one feels the most comfortable with. Once one has done all that, they can go ahead and place the kernels and light the candle, and voila.
So the physics portion for this experiment is inside the kernel itself. The kernel is like a little contraption that contains water, and this is a poorly drawn diagram, but hopefully this helps the explanation. There's a kernel with a little bit of liquid inside, and the liquid would be water. And once it reaches its boiling point, that's when it like increases the pressure inside of that little contraption, and the volume stays the same obviously, but the pressure increases, and then that's when it pops and it tries to have the same pressure as the atmospheric pressure, and that difference. Okay, and then that difference is what causes it to burst and make that popping noise.
As a chemist, I was asked to identify the chemistry behind this project. In this project, we are here to recognize that this area of chemistry is thermochemistry, in which is a branch of chemistry of heat that is concerned. In which is a branch of chemistry that is concerned with the quantities of heat evolved or absorbed during chemical reactions. Conduction and convection is demonstrated within this experiment. Conduction is the movement of heat through a substance by the collision of molecules. So how conduction is in this experiment is how the contact the conduction is shown when the candle, its heat is pushing onto the bottom of the aluminum can, and the contact of the cooler kernels to the hotter pan. What the fuck? Okay. Whoa.
What have you been saying?
I don't even know at this point. Okay. So the heat that is transferred by conduction is how the aluminum can is heated by the candle, where the candle is giving off heat to the aluminum can, where this aluminum can is giving off heat to the kernels, and these kernels will heat up until it pops and you have popcorn. And convection is shown by the hot air transfers the heat to the cooler kernels, and when it's hot enough, the air heats the kernels and then they pop.
Hello, this is biologist and also famous Dr. Garcia, and today I'm here to talk a little bit more about the popcorn kernel. Just so you guys know, popcorn kernels pop open once they are exposed to heats of over 100 degrees Celsius. And yes, indeed, may I tell you that is quite warm, because it is in Celsius. And another thing, as the physicist Dr. Barcenas mentioned, there are three parts to a popcorn kernel, and those parts being the pericarp, the germ, and the endosperm. Now, when popcorn is heated at about 180 degrees Celsius heat, the water trapped inside the endosperm, believe it or not, there is water, the endosperm, right? It turns into steam and builds up pressure inside the pericarp. Now, pressurized steam transforms the soft starch in the endosperm to gelatinous material, almost like Jell-O. I like Jell-O. It's very squishy, very soft, very flavorful, so I'm sure it's very delicious. And to add on, popcorn pericarp is able to retain the pressurized steam up to 9.2 atms, or also known as 135 psi. Now, when a kernel is popped, it gets 40 to 50 times larger, like size-wise, larger than its previous size. So it's even though it is small, it does get just a little bit bigger. It may not be like the size of my palm, my fist, but it does get larger than its original size. And now, when solving for to calculate the kinetic, sorry, give me 1 second, please. Now, if one wanted to calculate or find the kinetic molecular theory of gases, and this can be particularly used in this case of cooking popcorn, actually a great way, one can use the phase change of water into steam, of a liquid into a gas. Now, some laws that an individual may use and that we are in fact going to use are Guy-Lussac's law. And this can also be seen as P1 over T1 equals P2 over T2, I believe. Or, yes, I believe so. And the ideal gas law, which is PV equals nRT. Now, these two equations and all the data and all the facts that we get from our experiment of making the popcorn will help us calculate and see how many moles of gas were being produced or being used in the making of the popcorn. Thank you once again, and like I said, this is Dr. Garcia. I'm a world-renowned doctor and a biologist. It's my pleasure to inform you on my knowledge of the popcorn kernel itself.
Okay, so I'm an environmentalist. We did a popcorn maker, and how it's eco-friendly because of usually people don't recycle cans, and cans are really harmful to the environment. Instead of using a microwave, we used a candle, and the microwave releases all of these radiation type of things into your food. And radiation into your food, which gives birth defects into women, and also has effects into men. Instead of not recycling, you can use a tank to make a microwave or a makeshift microwave. And instead of using the microwave, you use a candle, which most people have candles, I'm guessing.